Okay, so we're gonna skip number 6 and we're gonna move to this formula. Guys, the formula is almost the same. The only difference in the formula is the number n. Okay, and n goes a division under rate, and it's also here with time. Okay, so n stands for the number of times that's compounded yearly. Okay, so if it's compounded every month, you would put a 12 here and here. If it's compounded weekly, you would put a 52 here and here. So in the word problem, that's the only thing that's different in one little sentence. So this still represents the new value, and this still represents the original. It's always new, original, 1 plus, 1 minus. All right, so let's try. An investment account pays 4.2 annual interest compounded monthly. So what are we going to use for N? 12. If $2,500 is in the account and is left to accrue interest, what will be the balance after 15 years? Okay, so if you try that, okay, do we know the total balance? No, so we don't know the new. Do we know the original? What's the original amount, guys?
25.
25, thank you. Okay, it says the account pays interest, so you're gonna get more and more. So we're gonna do 1 plus, okay, how do I turn 4.2 into a decimal? Move it 2 places, it becomes, good, 0.042 over, what number goes underneath that? 12. Raised to the 12 again and 15. You've got to use the 12 twice. Now, use your calculator and type that in. You have to check to make sure. You have to check to make sure that you're getting the right answer. If I were you, when I get to this fraction right here, this 1.042 over 12, I would use second alpha, or I'm sorry, y equals alpha. So I would type it in like this, 2,500, open parentheses, 1 plus. If you do y alpha, sorry, what is it?
Alpha.
Yeah, I went backwards, I'm sorry. Alpha y equals, let me try that again. When you get to here, if you go to alpha y equals, there's the fraction bar, and then I would do 0.042 divided by 12. So it's alpha y equals. Raised to 12 times 15. And you get $4,688.87. So $4,600. Almost double. Of course, it was 15 years. So that money took 15 years to double. It's very important when you're trying to decide on retirement. Okay, go to the next one. How come I didn't have to use log here?
Because you have time.
Right, because I wasn't looking for time. Thank you. Okay, number 8. Marta opens a bank account with compound interest. There it is again. If you see the word compound interest, that's the one where you have to use the N, the newer formula. She deposits $2,200 and leaves the money in the account to accrue interest for 5 years. The account is compounded twice a year, not very often. If she earned a total of $1,000 in interest, what's the annual rate? Okay, they're trying to trick us here. They told us how much she deposited. That's the original. Did they actually come right out and tell us the new? No. They told us how much she earned. How do I get the new then? If I started with 2,000, I'm not going to have 1,000. How do I get the new? Wait a minute, hang on, I'm earning money. I put $2,000 in my banking account, and I earned $1,000. How much money do I have now? Yeah, I add them together. Okay, this is just how much interest she earned. It says, what was the annual rate of interest? because she earned a total of $1,000 in interest. So cross that out and do 2,200 plus that number. Okay, so let's set up our equation. Our new amount was 32 something. 3256 equals our $2,000, our $2,200 we started with. And then 1 plus R divided by, what number there? R is our rate. We don't know the rate. It's asking what annual interest rate. We're looking for R. So under it goes in, the number of times that the rate is compounded per year. How many times is it compounded per year? Twice. And remember that 2 goes in 2 spots. It goes there, and it goes up here with time. How much time? 5 years. Okay, we're gonna solve for R. We're gonna get R all by itself. And remember what I told you. You'll get half credit for just getting the equation right. That's only halfway there. To get the other half, you gotta solve, which to me is the harder part. So to get R all alone, what's my first step? Good. Divide by the 2,200. Okay, so when you divided, you got 1.48 equals whatever's left here. I'm gonna go ahead and make the 2 times 5 a 10. So I'm still solving for R. What's next? Do I get rid of the 1 or the 10? The 10. Good, by raising it to the 1/10. So in your calculator, 1.48 raised to the 1/10 power. I got 1.04. Now what are you gonna do next? Subtract 1 and then multiply by, and then multiply by 2. So you get 0.08. What percent is 0.08, guys? 8%. Okay, we have one last formula. It's the easiest. Easy. Here we go. It's called half-life formula. Guys, half-life formula is what told scientists how old the pyramids are. Okay, or if they'll ever find the Ark when it was around, right? Things like that. Or the other thing half-life formula is used for is it's used for example, if you have your styrofoam cups, right? Scientists want to know how long is that styrofoam cup you just threw away going to be around. Okay, and this is what it means. Here's kind of a cool picture of what I'm talking about. Let's say you have a can or something, okay? And I say its half-life is 5 years. So in 5 years, I'm going to cut it in half, and down here is all that's left. Okay, in 5 more years, up to 10 years now, I'm here. That's all that's left. So in 10 years, it's here. In 15 years, that's what's left, and so forth. So half-life is how long it takes to decay to be halfway there. And they just keep repeating it until, technically it would never be gone, but until it's basically gone. You can always take half of something, right? Now, so let's try this problem. This is the formula. It's exactly the same as all the others. The first N is the new. The second N is the original. Okay, always, new, original, every time. Okay? The 1/2, well, that's easy. It's half-life. Okay? What do you think T stands for? Time. And the H stands for, just like my picture before, what was the half-life time of this can I was telling you about? I told you every 5 years it had a half-life. Right, so it's H stands for half-life time. So H stands for how long does it take for it to be halfway gone? So it's time over half-life time. So read the problem. The half-life of a certain substance is 3,000 years. So here's the half-life. Wow, that's a long time, guys. In other words, it takes 3,000 years for half of it to be decayed. Okay? Determine how much of 150 kilograms of substance, that would be the original, right, will remain after 9,000 years. Okay, so we don't know the new amount. That's what I'm asking. What's the new amount? What's the new amount? If the original amount, which was 150, use your formula. So there's your 1/2. And then it calls for time over half-life time. So how long is it going to decay? What's the time? 9,000 years. And what's the half-life time? Good, 3,000 years. So that's an easy one. Type it straight in your calculator. Okay, you're going to type it straight in by doing 150 times 1/2. And then raise to the power, and you can do that alpha y equals again if you want for the exponent. Just like that. And did you get 18.75 kilograms? Okay, try to set up number 10. Use your formula. Try to set up the second formula. Okay, what's the half-life time, guys? 40 minutes, that's the H. How much of a 3,000 milligram sample will remain? So this is the original after 2 hours. Okay, the issue is I've got minutes and hours, so right, good. Convert the hours, so 2 times 60 would be 120 minutes.
Can you also turn from 40 minutes to?
Yes, it's fine. So N equals 3,000 times 1/2. Remember the formula is time over half-life time. So how long did it decay for? 120 minutes, and its half-life, heck guys, its half-life is 40 minutes. That means every 40 minutes, half is gone. Okay, that's much different from the first one. So if you type it straight in the calculator, I think you get 375 milligrams.
Yep.
Okay, and we're done for today. Good job.